this sort of two-part workshop starts sort of with like a talking head kind of overview. So it'll be like a lot of like the Crompton talking show. And then next week has a little bit of hands-on. There's some software to download and we can like try some things and troubleshoot all together and try making and maybe even using some like existing linked open data. So this is us, part one. You also have the second half of the slides, so you can kind of look forward and see what we're doing. And I'm glad that Sarah, thank you for making all of the slides available in advance. I always find with these workshops, it's hard when people like move forward and I was thinking, oh, I want to go back and just check that other thing. Oh, no, I understand. You know, you can't move around in the slides. So you can move around in your own copies of the slides. And welcome everyone. This is what I'm hoping to talk through today, a little bit of what linked data is for and like what it could do, and how we might already have like encountered some of it in the wild, and what all the various pieces are that it takes to build up a little bit of linked data, perhaps from one's own projects. Some of this might be old news to some folks and new news to others. I know my research partner, Michelle, who is here, has said before that like, oh, she's gone to a lot of linked data workshops where people draw circles and arrows on a board, and then it sort of stops there. And actually, I must say, today's first run is very much of the circles and arrows on a board if we had had like a whiteboard to all sort of share together. And then we'll be doing a little bit more like hands-on stuff next week. Does anybody have any questions, concerns before we dive in? Well, then let's, in which case, let us dive in. You have the slides already, so you know, anyone who has scrolled ahead, I guess this will have like been sort of answered already. But one of the things that linked data is for is to give computers a sense of what's sort of possible in the real world, to talk about the entities, the people, the places, the things, the concepts of our real world and their relationships to one another. And I think there are very sort of like natural or naturalized, at least Western, often human ways that we think about these things, that we used to surmise like who someone is or what something is. And often that's the relationships to various parts of people's identity and their professional life, to the time that they lived and those sort of things. And that certainly being able to give this information to computers so that they can learn a little bit about people is at the heart, or places or things, of what linked data is for. Just by like a show of guessing in the chat, as I like scroll forward, we've got some person here, and just if that person's name just appears as a string or a random sort of assortment of letters, there's no way that the computer can necessarily know who that random string of letters is meant to represent. But if we start giving the computer a little bit of more context, like us, we do kind of work out like who we think this is. In this case, I put this person's name in Klingon from a website that was like a Klingon translator, and it had a lovely little subtitle that said, you know, this is just a translator for fun. I'm not responsible for whatever kind of tattoos you get with the thing that you put through here. Anyway, so yeah, if folks want to like guess, we know we've got a female writer and who was born in England, who has a born relationship to this date and a died relationship to 1941. Any guesses? And this person wrote A Room of One's Own. Haha, yes indeed. And To the Lighthouse, which has a genre fiction. And of course, this is enough to give us an idea of who this person might be. Good job, Susan. And to a computer, if it has all of this information about these places, it might also be able to infer kind of who this is, even if a computer won't automatically know that this string of letters specifically means Virginia Woolf, the author. So one of the things that we can do by using linked data to write out these relationships in like a computationally tractable or computationally understandable way is to give computers some of the context that we also use in order to represent and figure out, you know, who things are and where things are in the regular world. I'm sure there must be other Virginia Woolfs out there. I have known a David Bowie, a dear friend of mine, is in a long-term relationship with someone named Rodney King, you know, and it is really only by giving some of these other contexts that we can know that which of these people who have the same names as other sort of more famous people might actually be. Now, you know, linked data, I was reading a, some, you know, blurb on the internet that said that we were proposed to have the semantic 20s, like that the 2020s will be the age of linked data and the semantic web. Indeed, linked data is already here. There are lots of projects and certainly academic projects that are writing out content like this that computers can understand and using it to infer and find connections between people, places, things, and events. One of the questions is like, yes, linked data is here, but where is it? My father in sort of like the early days of online streaming would always be a little like, I don't know, like perplexed or like confused with like, you know, he would ask my siblings like, where did you get this album? They would say like, oh, on the internet. And you know, he would say like, I'm on the internet all the time. There don't seem to be any albums here. I don't seem to have like the latest Arcade Fire, you know, sort of thing. And that certainly linked data is a bit like that. It is actually running under the hood in various spots. And in terms of like actually downloading some and using some, you kind of have to know where to look at it. Some of the places where it may actually be out there in the wild and you may actually be interacting with the like graphic user interface that is drawing on it is out on the web. This image on the left is just some of the linked data that's thrown off by the Lesbian and Gay Liberation in Canada project from a platform that was built by MJ Suhanas at the Ryerson Library for Michelle and I. So it exists as like flat files, like these, just some text files that are under the hood there for search engines, for example, to read. It also exists in triple stores, which are linked data databases. And so there are lots of projects that have dedicated triple stores that either connect internally or that connect out to other linked data triple stores out there on the web. And here on the side, we have an image of LinkJazz, which is one of the sort of more famous projects that work with those. And so the world of like linked data is already out there and is already being used. Sometimes linked data of the Wolfian sort that we were sort of looking at underpins knowledge graphs, which are these large linked data sets that can be used to respond to natural language queries and can be used to infer information. So if you've ever put in a query of this type on the left, when was the author of Mrs. Dalloway born? If you can get back an answer like this one on the left, you've been interacting with Google's knowledge graph, and if you get those little pop-ups in the window on the far hand side, giving you a little bit of information from Wikipedia and information from elsewhere on the web, you are interacting with their knowledge graph, which has some of these linked data kind of properties in them. And so we can see already, even in the question, when was the author of Mrs. Dalloway born, that a structure like this one is useful, right? That having our data represented in this way, where you can say, where the computer can say, oh, okay, I know about a room of one's own, and an author is the kind of person who has a rote relationship, then I will know that that's Virginia Woolf. But they're really asking about when that person was born. This person has a born relationship to this date, then I know I can serve back this information about when Virginia Woolf was born. Now the Google Knowledge Graph is proprietary linked linked content. So, you know, we're not allowed to like go in and like have a look at what it is that they have built. Projects like Links are involved in making linked data that, where appropriate, is a little bit more open and that could be sort of used and reused, and that other projects could draw on. And also that really kind of helps with transparency, because we can, with projects like Links, look at the, we'll talk about ontologies in a bit, but the technologies that they're using under the hood in order to determine the answers to these questions, and that we can look at what are these kinds of relationships and how are they doing their ranking. And I must say, this is a like the sort of situation on the left where I can say, when was the author of Mrs. Dalloway born, is a vast improvement over like the search of the pre-1997 era. I'm sure there are lots of folks on this call who remember sort of what the plain text searching of those days was like, where many search engines were simply looking for words on a page and would return results to you based on the word you look for and how often that word shows up on a page. So that there was a time when, if you were searching for Jean Chrétien, you were more likely to get back a page that had lots and lots of jokes about Jean Chrétien because his name showed up over and over again, more likely to get that back than you would, say, something from the government of Canada. And in those days, like keywords, that was keyword search, and it was useful, but then also like often sort of hijacked by unscrupulous actors who just wanted to get people to your website. I'm sure folks will also remember like just like lots of like online poker and pop-up filled sites that you get to. You'd sort of say, oh yeah, look, this thing's all about Jean Chrétien. And then of course, under the hood, it's got white text on a white background that says Jean Chrétien over and over and over again, but was really kind of luring you there to see if you would spend your money on poker. That linked data search and something that has a graph underneath it is giving us sort of more nuanced content there on the left. But we do still live in the world of keyword search. In general terms, although we're not allowed to look under the hood, something like a Google search is, in addition to searching for the words themselves, also returning to you some of the pages that people link to most often. But you can see that I'm not getting a very nuanced response to my question, what poetry did Tekanawage write? It is letting me know that Tekanawage is the name of Pauline Johnson, a Canadian poet, but it's not answering my question in that like more nuanced way that I was getting with Virginia Woolf. So we can tell it like that definitely Pauline Johnson is not particularly like well represented in a graph format under the hood by Google's knowledge graph. Head on to the next slide. So we're heading into the semantic 20s, and there's lots of semantic web and linked data buzz, but indeed the semantic web and this way of connecting data in a way that's easy for computers to kind of parse the meaning and the context was a part of the original vision for the World Wide Web. This is a sort of like cliched and famous drawing of Tim Berners-Lee pointing out not just that it would be worth having HTML, which I think he's sort of most famous for, but also having this kind of structure in under the hood that lets us declare the relationships between objects, people, places, things, and concepts that could drive some of this more sophisticated search and let us infer some interesting connections. So connections of this sort would let me say, please bring me back all the places that the person who wrote this document in the center has worked at, and if we have a structure like this, then we could find that information out in a way that plain language search doesn't really let us do. So in a hand-wavy way, I have said the word triple. We've said linked data and semantic web without defining any of them, which can sometimes pet people the wrong way, like petting a cat from the back of its tail, like up over its head. Let us turn to some of those terms now, how they work, what they can do, what they look like in a natural language setting, and then what they look like as data that the computer can understand. This next set of slides I have shamelessly borrowed from links, so they may look familiar to folks who have heard talks about this from Susan and the team before. So here we have in natural language what are called triples. Triples consist of a subject, a predicate, and an object. A subject and an object linked to one another by a relationship. So we've got E. Pauline Johnson has nationality, Mohawk. Flint and Feather has genre, poetry. And Flint and Feather has creator, Pauline Johnson. And this kind of structure would let us ask questions like, what kind of Mohawk poetry can I find in this triple store, a large collection of data in this triple format? And if there are a number of poets who have nationality Mohawk, the computer could infer, oh, well, find me people who have the nationality Mohawk, and if our logic has been set up correctly, then as long as one of their publications, down here at the bottom, has genre poetry, it'll be possible to answer this question. So linked data lets us ask these kinds of questions without having to know in advance what the answer is. The others are challenged with keyword only searching, is that you have to sort of know in advance what the answers are without with just keyword searching. I might say, oh, what Mohawk poetry can I find here, and might get just a lot of things back about the word Mohawk, but not necessarily the nuance of separating out things that are poetry and that are written by people who have the nationality Mohawk. Linked data is also useful for inferencing. Nowhere in these three triples, which are in our imagined giant triple store, do we have an official statement that says that Flint and Feather is a Mohawk poem. But if our search algorithm for and parsing algorithm for like understanding what is in the database, if the logic itself says, oh, works have the same nationality as their creator, then we can get the computer to do a little bit of logic to work out that Flint and Feather is a Mohawk poem without having to state that the triple ourselves. So this actually like cuts down on the amount of data that one has to create from scratch, as long as the logic is sound, which of course is like a whole field of computer science in and of itself. So in natural language terms, all linked data is constructed of triples, which consist of subjects, predicates, and objects. Now, what does that look like under the hood? We'll talk about, if it's familiar to other folks, the idea of serialization next week. But here's one way of representing the natural language triple that we have here above. Flint and Feather has creator E. Pauline Johnson. That here we've got an XML element which opens here and closes here, and it's telling us that this entire element is about Flint and Feather. So here's our subject, and that Flint and Feather has the creator, E. Pauline Johnson. And as we sort of looked at when we were talking about the Virginia Woolf like Klingon example, the computer is going to have a very difficult time working out which E. Pauline Johnson this is and which Flint and Feather this is, sort of like thinking about the way the naming conventions of like indie rock bands have gone in the last I don't know, 10 years, it might be hard for the computer to know whether or not this is like Flint and Feather from Edmonton, who are very popular playing on late nights, or if this is a poetry collection. So linked data has a method for sort of solving this problem, and that is to give unique identifiers to every subject and object. And that this makes it a lot easier for the computer to distinguish that, oh my goodness, this Flint and Feather is indeed a book of poetry and not the very popular band from Edmonton. Not that there really is a popular band name that's from Edmonton, but it's never too late to start one. So here we have a URI, or unique resource identifier, that is a specific number that will own an address that will only ever belong to Flint and Feather. So the computer can be sure, yes, we mean this Flint and Feather. That we've got another identifier for Pauline Johnson herself, so she won't be confused with someone else who might have the same name. We also have a little stretch of code here that says, oh yes, and here's what a human readable label looks like. The RDF could also signal that this is a label in English, or in English and Mohawk. And here we have a version of our predicate, which we'll talk about in a little bit. So this is the RDF version of our natural language statement with URIs to help the computer disambiguate or tell the difference between all the things that might, when it comes just to like plain text, have very sort of similar names. Now, more images borrowed from links. That this is what linked data looks like. Not all linked data is linked open data that is available for others to use, but linked open data does have some considerable advantages. It is a standard that has been around since the birth of the web. So really the web that we interact with as the World Wide Web is designed to support linked data across the board. It helps us move from strings to things. This is the move from a string, which is hard for a computer to understand, to these URIs for concepts and for concrete people that can make that can help computers make meaning. And of course, because it's open, it does promote sharing, interoperability, reuse, discoverability, inferencing, and even serendipity. I hope in this workshop series we will eventually have some linked data and serendipity workshop from Kim Martin, who works on this subject. And of course, there we go. What does the best kind of linked data look like? This might also be a familiar diagram of the sort of hierarchy of getting one's content up on the web, and what is something that's easy for all the web crawlers out there that are looking to create semantic responses to things like our query about the author of Mrs. Dalloway. Something that's in like PDF or JPEG form is particularly difficult to parse computationally. If your data is in a proprietary format, but at least in a format that computers can easily read, you can kind of say you have 2-star linked open data, which is a proprietary format. As you move towards the open part of open linked data, it's certainly preferential to then have something in a non-proprietary format where no one has to rely on a third party to continue to support or update or accept fees from us in order to use their software. So a CSV, which is a comma-separated values spreadsheet, is also closer to being open linked data than something that's proprietary, like an Excel file. RDF is the data of the type that we saw there. It's using URIs, and it's drawing on ontologies, we'll talk about in a moment, which give definitions for the relationships between entities, and then full-on linked open data would be this stuff on steroids, all linked and aggregated and documented together. So we've said entities in this hand-wavy way. It's worth sort of talking about where those come from, and I've talked about ontologies in this hand-wavy way, and we can talk about what those are, what they're for, and where they come from too. So entities are people, places, concepts, things from the real world. I mean, or from like fantasy fiction, but fantasy fiction comes from our real world as well. But where do those URIs come from, right? We've got that long, what looks like a URL for E. Pauline Johnson, but who designs them? Where do they come from? This organization, this listing for the Virtual International Authority File, VIAF, might be familiar to folks. This is from the OCLC's service, which collects data about every author published in a number of contributing national libraries. So if you have ever written or published a book in Canada, you probably have a VIAF number and are right to be represented as linked data. So where do the URIs come from? There are lots of authorities that mint them. So there are lots of authorities out there that have created these unique identifiers for people. There's no like one URI minting service to rule them all. This is where I'd like to, in a moment, have a little bit of a breakout, and it'll probably be a getting to know you thing, because Sarah tells me it's possible to just sort of do it randomly, so you'll all be lumped together with various folks. What I'd like folks to do, and so I'm going to like walk through what I'd like you to do before sending you to it, is to just get a sense of like what kind of authorities are out there. This is my hope is to like counter that problem of like, but where is this stuff on the web, or like who is minting these entities? Almost like, you know, I'm on the internet all the time, but I never seem to have albums, you know, show up to me. That we will like overcome that challenge here. So what I'd like folks to do is to head to Wikidata. Here's the URI for that, wikidata.org. This is a sister project of Wikipedia, also run by the Wikimedia Foundation. So it's one of the many sort of suites of projects that they run. It's the newest one in the Wikimedia suite of projects, and dates from 2012. It contains structured data, which was originally drawn from the structured data inside the info boxes inside Wikipedia's, and now is something that is, you know, open and editable in the best Wikimedia project sort of way, and can be used, that data that's in there can be used to feed info boxes in all the different language Wikipedias, and it's also available for us to query. So it's what we'll be working with in this workshop and in the next workshop, not because it's like the best data source in the world, but because it has some fairly like user-friendly interfaces and a useful query service that can help us out. So I'd love when folks get into like those breakout groups to head to Wikidata and really just to search in Wikidata for a person or a place that interests you, and then to scroll down to the bottom of the page and to have a look at the bottom of the page. You'll see some existing IDs and authority files. Have a look at a few of these, and I'd just love to know, you know, if you choose them, who are the people who are maintaining that authority record? You can click through, or you can Google search the name of theirs in the little example here on the slide, which I hope people can see on their own screens and copy the slides rather than the tiny thing you're seeing on your screen via mine. Who are the people who are maintaining those authority records? So look at a few of them. Who do those authorities seem to be for? You know, we've seen that link from VIAF. It's really a list of people who are authors. It's not going to be very useful for like sports aficionados, because it'll only capture sports folks who have written books. And then also, if you'll go to like 2 or 3 of the authority files for the person who you've chosen, what does that authority file have in it? And what are they recording? And then are there any like contradictions between what is being listed by one group or another? Does the Library of Congress say the exactly same thing about that person as, I'm looking at my example here, Clarion D does? I also want to talk about like where those predicates come from, those connector terms that are connecting entities to one another in this process of making meaning out of our linked data. And so here we have our sample triples, has nationality, has genre, has creator, connecting all of these various pieces together. That predicates come from ontologies, and ontologies are also computationally tractable. They're full of rules about how entities can operate and how they work in the world. We have this in the like sort of natural world as well. You know, if you have the idea of an entity as a building, for example, we might say, oh, a building is a type of entity, and buildings cannot be in the has identifier number to a SIN number, but a person could have a has identifier number relationship to a SIN number, because people have SIN numbers, but buildings don't. Or we might say that trees could be in a has ring number relationship to a number of rings, but we wouldn't say that a person could have ring number relationship to a number of rings, because people don't have rings. So ontologies give us these relationship terms, but they're also full of rules about what kind of entities can be connected to one another with what types of relationships. And they give us classes of entities too. So the idea of a person, and the idea of a building, the idea of a tree, and then we might have entities that are specific people, specific, I don't know if there are specific famous trees, specific entities. Actually, that's not true. I used to live in British Columbia. There's some very famous trees there. We would go see some of them specifically. I would love to do the same kind of breakout exercise, but with entities, so that folks can also get a sense of like what entities are out there, what they are supposed to record. We might be a little shorter with this one so that we have time for questions afterwards. But there are lots of ontologies out there that are created by various labs, working groups, commercial entities to represent the world in the way that they need in order to do sort of referencing. So the kind of ontologies, which are these rules for the relationships between entities that are designed by commercial groups like schema.org, which is supported by a bunch of search engines, they have different kinds of needs and different kinds of things they want to say, for example, about personhood, which might be quite different from what, say, the Canadian Research Writing Collaboratory wants to say about historical people. So there are lots of different ontologies out there with various levels of specificity and various rules about the way that entities can interact with one another that suit the needs of whoever authored that ontology. And for projects that are working with existing linked data or who are constructing linked data and maybe even making their own ontology, it's worth sort of thinking about the worldview that you need for your data set. What are sort of the meaningful relationships, and what are the things you want to represent about the world, and how specific do you need to get, and how broad is sort of just fine for you. So the next sort of like breakout thing, I think also just for 5 minutes and be kind of quick, that I'd like folks to do is to click through to linked open vocabularies. This is also an aggregator that has a number of ontologies listed in it. You can search for sort of various terms. You could also just click on any of the ones sort of here. What it will show you, I'm gonna find one I know nothing about. The larger ones are used behind lots and lots of projects, and so they will be sort of familiar. I am now doing that live demo thing they say you should never do, where you just choose something live. What this site will give you is a short description of what this ontology is for, who created it, but then also which ontologies use it, and then which ones it uses. And so it's worth looking at a few of these to sort of see, are there some ontologies out there that like everyone uses, or that seem to come up again and again? And then what's the sort of domain for the one that you have chosen? Like if CT-log is using ARCO, why, what is CT-log with? Have you stumbled into the world of like marine biology ontologies, which might not be useful for folks who are working in literature, or have you stumbled into the world of literature, and it would be very hard to say anything about the world of marine biology from where you are there. For folks who did click around, you might have found that like, you know, some have homepages and documentation that is like easy to understand, to sort of get started, and seem to have a large community around them, lots of workshops about like how to use their stuff. And then there's some that might sort of be smaller side projects or things that no longer have a community around them, but there's still sort of a record that at one time they existed. And certainly some ontologies are used primarily like in-house by particular research groups, and others like schema.org are used kind of quite broadly. And in which case I wanted to just like close this sort of like talking head show like overview before we do some things with a little question about like, so this like the semantic web is here. We are already interacting with it a little bit. There are websites that are using ontologies like the ones we've looked at here, and uniform resource identifiers like the ones we've looked at here, and already your search engines even are interacting with them, as well as there being lots of scholarly and other projects that are using linked data. So you may be interacting with linked data like all the time and just didn't know it because it's, you know, quietly kind of kept under the hood. Next week, I want to talk about how to find linked data, how to query it, how you might want to sort of use it in your own projects. We're also going to talk about how to make some linked data. Because it is just an hour and a half, we'll be making some of those flat files like you saw on the third or fourth slide, rather than everyone installing their own triple store and populating it with something and carefully choosing an ontology that relates people and places and trees and concepts to one another in, you know, ways that we think of as responsible, but that is like a sort of like further step of what we might do when it comes to implementing and making the most of linked data. Also, since the semantic web is kind of here already, it is something that we can contribute to. I'm sure folks may have sort of heard through their university communities about the ORCID ID system, where, you know, there's this push to get us to put data about our publications and about ourselves in the ORCID platform. And I definitely like wondered early on, like, oh, is this like another like academia edu, like some, you know, to be commercialized, you know, mining venture? But no, indeed, ORCID is another one of these authorities, bodies that is looking to create structured data about the academic world. So if you have an ORCID ID, there's already a, you know, URI out there that represents you, and so you can contribute yourself as an entity to the world of linked data too, by populating content like that. It's also definitely like worth getting involved in projects that make linked data, like links. You know, this is a very generic workshop, but you know, links is a good thing to do. And the reason that I would say that it matters and is like worth doing is that when there are groups like links that are making ontologies, they have, you know, specific interests, and specific interests that might speak to our interests if you're coming from the humanities, in how data is represented. You know, what it is that a commercial search engine that is contributing to schema.org thinks it's necessary or useful to say about a person might be quite different than the sort of maybe more nuanced, dare I say, sophisticated things that a group like Links might want to say about a person at the level of an ontology. And I think this is actually a place where humanists have a lot to offer. You know, that definitely the humanities disciplines are invested in thinking through nuance and difference. And so one of the things that we can contribute, even if we're not, you know, like don't come out of this workshop feeling prepared to like write an ontology from scratch, is that when you see these sort of calls for feedback on ontologies, bringing our humanities habits of mind and our like subject expertise to that feedback opportunity means that we could intervene and create more semantic web data that is thoughtful and responsive in the ways that that the humanities are. And there's certainly lots of groups in humanities domains and in sort of sister domains like the galleries, libraries, archives, and museums communities that are working with and creating linked data, like the Canadian Heritage Information Network or Ingenium, which runs the Science and Tech Museum and special collections in Ottawa. So there are lots of ways that we can be involved, sort of like no matter our level of technical expertise.